Thank you, and good morning, everyone. Very glad to see so many of you here, and thank you very much to nasscom for the invitation. Believe it or not, despite having worked in this space for far too many years, this is my first trip to India, and I'm very glad to be here, and hopefully it will not be my last. So, what's next in engineering? Seizing the future amid global shifts. We're already in a new era of manufacturing. We all know this. We've been through the first industrial revolution back in the 18th and 19th centuries, the second and third industrial revolutions that destroyed the power of the artisan to introduce mass production, that began to take away the need for human labor by bringing physical automation. And now with Industry 4.0, we begin to augment or sometimes replace the human brain, human creativity with automation, machine learning, AI, and other technologies. Some people, including the European Commission, now suggest we're entering the age of Industry 5.0. Maybe. I think a lot of the work we do at Forrester, looking at this talk of Industry 5.0, would suggest that actually what people call Industry 5.0 today is really just doing Industry 4.0 properly. And I'll talk a little bit about that in a moment. There are a range of technologies, and we heard about some of them from Kishore earlier, a range of technologies that are driving the improvements, driving the change, driving efficiency. We talk about things like digital twins. We talk about things like 3D printing. We talk about things like industrial IoT platforms and AI and machine learning and a whole range of other technologies as well. And they're all great. They're all useful. They're all helpful in used properly. But if we just focus on this technology, and if we just focus on the individual technologies, we actually completely miss the point. It's far more important to move beyond those individual technologies and begin to think about how they plug together. So, for example, the first picture on the left there, and I apologize for the resolution. This was one of Amazon's smart buttons. And others have done it too, but Amazon really made a lot of noise about it. And the idea there was, you're sitting on the toilet. I apologize for this conversation. But you're sitting on the toilet. You get to the end of whatever you're doing, and you turn to the toilet roll, and that is what you see. And the whole value proposition, the whole story was push the button, and Amazon will send you more toilet roll. And that's great, that's nice. You know, Amazon in a lot of cities around the world will deliver within an hour or two. Or in other countries, maybe next day. That's great, that's useful, that's nice. It does nothing at all to solve the problem you are facing, sitting on the toilet. Do you really want to sit there until tomorrow? And we see this kind of thing with technology again and again and again. There was a big new rail contract awarded in the UK about 5 years ago. And it came with new trains, and it came with new service models, and it came with lots of AI, and lots of analytics, and lots of outcome-driven business models. And one piece of that was sensors on all the bins in the train carriages to tell you when the bin was nearly full. And the technology approach said, put an IoT sensor on the bin and you trigger an alarm when the bin is full. Again, like the toilet roll, it completely misses the point. Because by the time a cleaner arrives to empty the bin, it isn't a full bin anymore, it's an overflowing bin. And the floor of the carriage is also covered in rubbish. So, a technology approach that completely failed to understand the actual problem. Take the same technology, but set the alarm to go off at 80% full, or 90% full. And then a cleaner has come and emptied the bin before it overflows. So we need to focus on the customer outcome. We need to understand the thing we're actually trying to address. We also need to understand the business model implications, thinking about how this changes the way in which we build, sell, and maintain products throughout their life. And we're seeing lots of interest at the moment in these usage-based or outcome-based business models. And again, I'll touch on some of those in a moment. And the final piece around connecting stakeholders across the organization. I'm sure you've all seen examples of this. The innovation team, or the digital team, or the transformation team, or whatever they're called in your organization. They come up with some amazing cool new application, or some amazing cool new technology. And like gods on Olympus, they hand it down to the poor worker down on the factory floor and say, here you are, poor worker, I have transformed your world. And the poor worker, certainly in Europe, and I'm sure probably here in India too, would say something I will not say on a public stage, and drop the technology, or break the technology, or throw it in a corner, because it actually did nothing to help them do their job. It was just another thing to have to charge, or another thing to have to learn how to use, or another complicated workflow that got in the way of doing the job they actually wanted to do. There's a company in Europe, one of your sponsors actually, called Schneider Electric. And one of the things they always say, their digital team always says, we cannot hand these technologies down like gods on a mountain down to the poor worker. We actually have to first get down there. We have to walk in their shoes. We have to feel their pain. We have to understand what their problem actually is, and then talk about how technology might be able to help them. And sometimes the answer is some cool, amazing new technology. Sometimes it's rethinking a workflow a little bit. Sometimes it might actually just be moving the box a little bit closer to the worker so they don't hurt their back every time they have to turn around and twist to pick it up. So understand those stakeholders, get close to them, actually listen to them. We talk about 3 innovation horizons, and I'm not going to go through these in detail, but we see these technologies being introduced over 3 broad phases. Firstly, over the next 2 to 3 years or thereabouts, we see some ad hoc innovation, taking technologies we already have, taking processes we already understand, and just embedding them a little bit more. In the middle there, over sort of 5 to 10 years or thereabouts, we see bigger changes that require some more work, some more effort, sometimes some regulatory change to actually drive it through. And then on the far right-hand side, the longer term stuff, the 10 years or more, including things like moving manufacturing into orbit. And we're certainly not ready to do that today. But the first experimental licenses are being given out by the European Space Agency, by NASA, and by some other agencies to say, let's see what happens if we begin to move manufacturing into orbit. So the thing I want to spend most of the next 14 minutes and 19 seconds, according to that clock, talking about are 4 big trends, and give examples of each of them as I go. And at Forrester, as I'm sure with all of our competitors, we spend a lot of time talking to clients like you about the day-to-day problems you face, the challenges you're working on, the direction you want to go in moving forward. And all 4 of these ideas have come up for years. None of them are particularly new. None of them are particularly innovative. But what's interesting is that almost every conversation I have now touches on some element of all 4 of them. So they're coming together. And I'm going to look at each of them in turn now. So the first of those 4 big trends, the shift from grease to code. embedding digital into the physical products we've been making for a century or more. And we see things, ooh, that went away, that didn't, that's okay. We see things like the rise of product as a service that I already mentioned. This idea that instead of selling a physical asset, you sell the outcome. You sell miles flown by a jet engine, like Rolls-Royce. You sell numbers of passengers carried on a train, like Hitachi Rail in the UK. You sell liters of compressed air instead of a compressed air machine, like Caser Compressor. And to do that, you need lots of IoT. You need lots of connectivity. You need lots of AI and machine learning. And you need lots of understanding about the process you're actually trying to touch and improve. Those trains that I mentioned earlier with the bins, there are 3,500 sensors on every train, measuring vibration, wear, temperature, humidity, and the bins. Digital twin, and Kishore mentioned digital twin earlier as well. We're beginning to see these break out beyond the individual use cases where most of the attention goes at the moment. I drew this diagram years ago. The three broad areas where digital twins are deployed. The design twin, the process twin on the factory floor, the service twin once these assets are actually out in the wild being used by real customers. And for years, we've talked about this mythical idea of the digital thread that links them together. The idea being the data that you use to design the asset is also used to manufacture it, is also used to sell it, is also used to maintain it out in the field, and is also used actually to decommission it at the end of its life. We've talked about it as a vision, as an ideal for a very long time. The reality is we almost never manage it. We tend to maybe go from design to process, or process to service. We never really close the loop and get the real value from the twin. It's not because of technology. The technology's there. It's people and organizational silos. Designers don't talk to manufacturers. Manufacturers don't believe a word a designer says because they're off in some office somewhere, air-conditioned, with a nice computer and lattes probably. And manufacturing are saying, what do they know? They don't get their hands dirty, they don't understand the real world. And those sort of organizational and human barriers get in the way of a lot of this. So we need to work with that too. Digital twin, sticking with that idea. Lots of people talk about digital twins. Far too many of them are just a pretty picture, actually, with no real connection to the asset. So some work we did a few years ago suggested there are 6 things a digital twin has to have. If it doesn't have all 6 of those, it might be a pretty picture, which has a use, but it's not a digital twin. It might be a simulation, which is useful, but it's not a digital twin. So you need a physical and a real. There has to be a twin. There has to be a real thing. There has to be a connection between them, and they need to update one another bidirectionally. And there's a whole lot more we could dig into on that. The second of our 4 big trends, rethinking global supply chains. We've heard a lot this idea that globalization is dead. It isn't. Globalization is not dead, but it's absolutely changing. It's evolving, and manufacturers are adapting and responding to that as well. And we see, for example, a lot of work being done to rethink where manufacturing gets done. We saw some of this during the pandemic. We saw some of it with the global supply chain challenges immediately after the pandemic. We actually saw some of it, the previous US president and his attitude to some countries like, for example, China, affecting how US manufacturers thought about that place where manufacturing gets done. So we're seeing much more interest in nearshoring. Things like the Inflation Reduction Act in the United States, pouring billions of dollars into encouraging manufacturers to come home. We see the same thing in Europe. We see the same thing in a number of other markets as well. And what we're now seeing is the reality that actually that was a little bit harder than politicians suggested. It's one thing to say, yeah, I have billions and billions of dollars to open a new factory in my state. And everyone will shake hands and plant a tree and lay the first foundation. Actually getting a factory up and running is a little harder. And we're seeing that play out now as some of these promises are toned back a little bit. The other one, and this is probably of particular interest to India, is the rise of friendshoring. So we're seeing, again, because of some of the disruptions with China, for example, we're seeing Europe, we're seeing North America, we're seeing some other parts of Asia place very strong bets with countries they call their friends. And investing in those, even if it might not be the cheapest or the best place to get work done today, they're pouring the money in to increase the capability of those markets. And some interesting trends to play out there. Alongside this global reshoring, rebalancing, we see technology playing a role. Things like 3D printing becoming more prevalent in manufacturing processes. They don't replace every manufacturing line. They don't replace every subtractive manufacturing workflow. But they're becoming increasingly part of the story for design, for prototyping, for jigs and fixtures, for spare parts, and sometimes for specific manufactured finished goods. The automotive sector, for example, using 3D printing. And this is one of the ways you lower the cost of doing manufacturing closer to home. Because a 3D printer is probably cheaper than a German worker, for example. Microfactories driving the same kind of economic shift. And this is a company called Machina Labs in the States. And they're deploying robots like this one in very small facilities to take on some subtractive manufacturing processes. This particular one is deployed at a US air base in Georgia, and they're cutting down the time it requires for a spare part from about 6 months to a couple of weeks. That's important. That drives change. Third of our 4 big trends. We have 5 minutes and 27 seconds to go, so I better speed up just a little bit. Third of our 4 big trends, all the sustainability stuff. And this, again, we're seeing a shift. We're seeing a move away from sustainability in manufacturing being one of the sort of nice-to-have things on the side. Sustainability is when the chief executive plants a tree outside your factory and says, we're going, look, we're planting trees, and maybe we will buy some offsets. Manufacturing is dirty, sorry, we'll buy some offsets. That's not enough anymore, and that's being increasingly recognized in markets all around the world. But it's also, and Kishore said this too, it's also about recognizing that sustainability is not just about compliance. It's not just about following the rules. It's actually about finding new business opportunities, new ways to make money, new ways to engage with customers, new ways to bring products to market that are better for the company, better for the customer, and better for the planet. And it can be done. We see, for example, growing interest in green power. Things like coal are not going away anytime soon. We need them. We need that power. We need the other things we make from fossil fuels. Plastic, for example, nylon, and other materials. But growing interest in green power. Things like wind, things like solar, absolutely. But this isn't wind power. This one is tidal power. So it's a wind turbine in the water. And one of the problems with wind power is it's unpredictable. You're never quite sure when it's going to be windy. Tides aren't like that. This tidal barrage is off the north coast of Scotland. It's one of the biggest tidal spans on the planet. So the tide comes in and goes out twice a day. You know exactly how much power you're going to get, and you know exactly when you're going to get it. Now, at the moment, this is only about a 2 megawatt facility, so it's not going to make a difference to anyone particularly, but it's allowing us to learn what's possible. It's allowing us to work through some of the opportunities. Circular economy, I talked about this as well, this idea of finding the ways to make sustainability work and finding ways to find new business models on the back of it, rather than just complying and following rules. We see, for example, BMW with their I Vision Circular. This is a concept car, but the idea is it should be 100% made from recycled material and should itself be 100% recyclable at the end of its life. That's the vision. The reality isn't quite there yet. But think of all the things you have to work out to make that work at scale. You need a scaled source of recycled material. You need a supply chain throughout the life of an asset that is able to take material and recycle it, or put new material into the process that has itself come from a recycled source. Anywhere in the world, not just in Bavaria, where the car is made at the start of its life. The fourth of our 4 big trends in 1 minute and 45 seconds, augmenting the human worker. And the important point there is augmenting the human worker, not replacing them. Robots, for example. This is some data from the International Federation of Robotics. 1,012 industrial robots per 10,000 human workers in the most automated country in the planet, South Korea. China is about 400 per 10,000 workers, but it has more robots than the rest of the planet put together. It's just a very, very big country and market. The numbers for India, and I apologize for having to read them off a bit of paper, but I can't read that. So India has 150 robots per 10,000 workers. It's in the top 10 for raw numbers of robots, but doesn't even make the top 20 for this robotic density number. That's not surprising, but that's where India is at the moment. Physical automation, robots do a lot of things. We need to focus on the task we're automating, not the job you might want to replace. A human worker does lots of different tasks. Some of them are very well suited to automation. Some really aren't. Various levels of autonomy that are worth thinking about as well. So sometimes it's about the human telling a robot what to do. Other times it's about robots beginning to make some of those decisions on their own. The reality is that is a very long way off. But robots are getting more capable. We're seeing, for example, cobots like this one, able to make you a cup of coffee. And just the final point I wanted to make. I said this is about augmenting the human worker, not replacing them. It's about allowing those human workers to do what they're good at. Allow the robot to do the dull, the dirty, and the dangerous. Free that human worker up to do things a little more valuable, a little more empowering and engaging. And to do that, we talk about this thing called the automation triangle. And it's a recognition, and this is the final slide, a recognition that almost every task in manufacturing is some combination of 3 things. Physical automation, robots. Software automation, so AI, machine learning, robotic process automation, and the like. And the human worker. But it's about making sure that human worker is as empowered as possible to do their best possible task. And with that, thank you.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.